Okay, next up we'll talk a little bit about vane pumps for aircraft. Usually they're not used for hydraulic purposes, they're used for other applications. We use them for driving magnets in many aircraft anyway. There's a couple of different styles of them, but most always they use centrifugal force to hold the vanes against the case wall. So when the pump is rotating, centrifugal force is used to kind of push the vanes directly to the wall itself. There are some styles of these vane pumps that where the vanes are allowed to somewhat intermesh with each other on an eccentric in order to kind of do the same thing. So that's what they're showing you in this illustration. So that allows for the vanes to kind of come in contact with the vane wall or the case of the pump. But to give you an idea of kind of how they work, or at least their application, this would be a picture showing how they're mounted on an aircraft engine. They're used for driving the artificial horizon and the directional gyro, the two primary gyro instruments in the aircraft. They can be used for either pushing air through the instrument case or pulling air through the instrument case. So they're called either vacuum or pressure pumps, but again, remember, pumps don't really create pressure, they just create flow. But we can push air through the instrument case or we can pull it. The fittings that attach to a lot of these vane pumps are what we call low-loss fittings. And if you look very carefully at them, they're very different than what you'd find for hydraulic type connections. First of all, what they have that attaches to the hose is a beaded connection. So they've got a bump on the end of the fitting that the hose fits over, and usually a hose clamp goes on top of it. More commonly, too, you'll probably find AN type threads that are used, or I should say pipe threaded connections that are used inside of the pump to attach it internally to the pump. Basic classifications for vane pumps, we have two different types. We have pumps that are called wet pumps, and then we have pumps that are called dry. The difference is the method of internal lubrication. With a wet pump design, the idea is we'll use engine oil under a slight positive pressure, or at least under splash, in order to internally lubricate the pump. If you look very carefully, I don't know if you can see it, but there are tiny little holes that are in the base of the flange of the pump. Those provide an entry for engine oil from the accessory dry through splash and spray to lubricate the vanes of the pump. That oil is necessary also to seal the vanes against the case wall. The vanes in most of these wet pumps are made out of steel, and obviously you need some type of lubricating film between the wall of the pump and the vane, but it also provides the seal as well. We've got one of these pumps, I think, someplace in the shop. I can kind of show you what it looks like internally. The common manufacturers in the past of wet pumps were Pesco, Eclipse, Garwin, and Romex. They're expensive to manufacture, and in the beginning about 1970 or so, almost all of the wet pumps were became kind of an obsolete design. Most airframe manufacturers at that time elected to use a different style of pump in aircraft in order to control cost. The pump of choice in that case, or what they developed from that point going forward, were dry pumps. The dry pump uses a different type of internal construction. The vanes inside of the pump are made of graphite or carbon. And the method of lubrication is by, through rotation of the pump, the vanes just progressively wear slightly in order to produce a lubricating graphite powder that lubricates internally, lubricates the pump internally. There's a lot of different manufacturers of the vane pumps. Airborne, I don't think currently makes the pump, their pumps anymore, but another company came along that absorbed Airborne as a company, Edo, and they continued to make these vane pumps. A common manufacturer today of vane pumps now is Sigmatech, and there's another one, Tempest, that's another brand name of usually a dry pump. And then Rapco, they started out as a pretty much an overhaul facility for dry pumps, but they now manufacture their own version of dry vane pump themselves. Let's take kind of a little bit of a look at the wet pumps. The wet pumps, again, they require oil from lubrication, aircraft engine oil, that enters through tiny holes that are in the flange of the pump. These pumps are also commonly protected with a drive shaft, a spline drive shaft that probably has got a weak link on it as well. So it's kind of a shear shaft design. But there's something kind of more important internally inside of a lot of the vane pumps that are wet. They've got a spring on the inside that provides a bit of give. And that's important because it prevents a shock loading from damaging the vanes inside of the pump. I've got a kind of a poor illustration of one of these springs internally, but it's located in here. And it's a kind of a counterwound spring, like a leaf spring that's internal inside of the pump, and it prevents shock loading from actually damaging the vanes inside of the pump. This picture also shows you too, kind of the lubrication pathway for oil inside of the pump. If the pump is used in a place where there's no access to engine oil for the flange of the pump, the manufacturer also of the pump provides ports for lubricating oil to enter into the pump. But more often than not, these ports are plugged and will use engine oil through splash and spray that enters into the ports of the pump for lubrication. But this is kind of common for most of the pumps. What else I can tell you about the wet pumps? They're mostly obsolete. They cost a lot of money in order to manufacture. There's possible substitution if you're having to replace an aircraft vane pump that was originally equipped on an aircraft that was a wet style. You're sometimes in a bit of a problem because if you look in the type certificate for the aircraft, only certain types of vane pumps are approved for installation on the aircraft as standard equipment. So this leads to a little bit of a problem. If the original vane pump has failed and you need a replacement, sometimes you can't find the pump that was originally installed on that aircraft as a direct replacement. Fortunately, there's other manufacturers that have STC conversions that allow you to install a different manufacturer's pump in place of what was there. But you'll have to check a list for applicable aircraft to verify that you can find a pump that will work. But again, especially with these Eclipse pumps, they're really old. So to try to find something, if it's installed on an aircraft, you may have a little bit of trouble trying to do something like that. The spline coupling, this shows you can't see it behind the spline coupling, they commonly have like a spring, a wound spring. It's almost like a leaf design that gives a little bit to prevent shock loading on the drive shaft. Something else too, the speed of these pumps is kind of critical. They rate the pumps in terms of what they're normally able to sustain. And again, substitution of the wrong pump and the wrong application for an aircraft can lead to overspeed, which wears the pump greatly. These are some common drive speeds for different aircraft engines, but some of the Lycoming single-cylinder aircraft engines, the accessory drive to the aircraft engines, that's a 1-to-1 ratio, but on some of the Lycoming 6-cylinders, it's a 1.3 to 1, so the accessory drive is running a little bit quicker. And also, too, on some of the Continentals, the 6-cylinders, those things run at 1.5 times crankshaft speed. So just be aware if you sometimes substitute a pump in, you might be unnecessarily damaging the pump because it's being driven at an appropriate speed for the particular accessory drive that it's connected to. Most of the wet pumps are protected by a couple of different means. Sometimes they'll have a tongue inside of the pump that will provide for kind of like what a shear shaft does in some of the, like the gear pumps have. And then you may also find a regular shear shaft, just like they use on some of the Pesco pumps. But more commonly, what you find attached to the dry pumps for the protective device will be a frangible type of plastic connector. And this shows you one that's actually been broken. They use a kind of a pin type connector. I'll see if I can pull up a picture on the internet to show you a little bit better. But it's designed to fail under torque loading. for the same reason that the shear shaft fails on a lot of the gear type pumps. If there's an excessive amount of torque as a result of the pump binding internally, the piece of plastic or the coupling actually separates or shears, and then the pump is sacrificed. The other accessories in the gear train will continue to operate normally, but again, this is how they do it in a lot of the vane pumps that are the dry style of pumps anyway. That's what they have. Some examples of some worn drive coupling. You should always inspect these things too. If you're going to be replacing a pump, because sometimes not only is the pump damaged, but also the drive shaft as well. Spline coupling, this is the pump removed. The coupling is actually still inside of the engine. It's still there. So just beware that that thing may be worn as well. Pesco pump, this one is a wet pump. You can see the operation of it. It has vanes that slide back and forth. They're slotted in order to allow the vanes to move back and forth in order to conform to the wall of the pump. Bearings in the pump are usually ball bearings that are caged, and the oil also lubricates those things as well, not only just the vanes against the case wall. Many of the wet pumps are considered to be bidirectional. And what we mean by that is it doesn't matter which way you turn the shaft of the pump will work in either direction of rotation. And that's kind of important. Some pumps have canted vanes in them. If the vanes are canted in a particular direction, in other words, the slot that's cut on the rotor is cut at an angle, so it provides for an angle on the vanes. Those pumps are usually unidirectional pumps. They should be driven in one direction of one rotation only. The big advantage of vane pumps that have canted vanes is supposedly it reduces the tip velocity and prolongs the life of the pump. So it cuts down on the tip speed of the individual vanes as they're moving. But with many of the pumps that are wet pumps, they're radial designs where the vanes actually come out in a radial fashion from the rotor of the pump. So they can generally be driven in either direction of rotation. Always check to make sure you know what you have. So again, sometimes also on the pump too, I don't know if you can make it out in this illustration, there'll be some markings that are on the pump that'll kind of give you a clue. See, you've got two ports here, one's an in, one's an out, but they're both labeled as in with an arrow pointing toward each other. What this kind of tells me is it's going to be a bidirectional pump. I can drive it in either direction of rotation without having to worry about damaging the pump internally. Anything else too? Lubrication of the oil path throughout the pump. Here's the drive coupling on some of them, and again, they use that spring inside of it to kind of minimize the shock on the vanes, minimizes torsional vibration on some of them. And this is kind of important too to know about wet pumps that are lubricated by engine oil. Once we've achieved the goal of getting oil in the pump for sealing and lubricating the vanes, we have to kind of rid that pump of the oil. It'll happen in the course of operation simply because what's coming out of the outlet of the pump is going to be air under pressure, but also there's going to be some oil that's emitted from it as well. Well, we have to have mounted downstream of the discharge pump point of the pump. You'll have to have an air oil separator. This is a picture that I took out of one of the manuals for the setup of a wet pump. What they want to do is they want to verify that actually oil is being emitted from the discharge of the pump when the propeller is rotating. So what they do is they just momentarily operate the aircraft engine, and then they put a piece of paper over the discharge side of the pump in order to capture a little bit of oil that comes out of it to verify that the pump is properly lubricated. But what I'm telling you is when this particular wet pump is in operation, what is required downstream of it would be an air oil separator. That air oil separator is necessary to return the oil back to the engine sump. So you have to have that for a couple of reasons. Number one, you'll eventually deplete the engine of oil. So you're not scavenging the oil back to the engine sump, and you've got a fixed amount of oil from the being supplied to the aircraft engine. Eventually you're going to run out of oil. The other thing too is you'll pollute anything downstream with oil if you don't capture it. A lot of these wet pumps are used for a different application. If we have to inflate pneumatic de-icer boots on aircraft, the discharge side of the pump is used as a supply of air under pressure to inflate pneumatic boots. So there's a valve called a distributor valve that's downstream of the pump, the discharge, and you obviously wouldn't want oil getting into that, or even into the boot itself, which would cause deterioration of the rubber. So again, we need an air oil separator in order to capture the oil at the discharge and send it back to the engine sump. Some particulars about these wet pumps. They're just like any other constant displacement pump. You're going to have regulation of air under pressure. So as you might guess, if we're using it for a vacuum system, you have to have a vacuum regulator in order to control the pump. The vacuum regulators are pretty simple. They're suction regulators, and they allow air to be bled in order to control the degree of vacuum that you want. So they're pretty simple. In the general class, I think you had to plumb an instrument mock-up, and you should know that, at least anyway, you have to have a kind of a suction regulator in order to control the amount of vacuum. With a wet pump also, you're going to need an air oil separator. The air oil separator is pretty simple. Most of them are just box-like assemblies or cylinder assemblies with internal baffling inside of it. And the air and the oil enters into one port. A drain is provided at the very bottom of it that's got somewhat of a close-fitting filter or screen in it. And then another port is provided in the air oil separator that allows clean air to exit. But it allows air to, or I should say oil, to be ultimately returned back to the engine sump. Again, most of these wet pumps are considered to be bidirectional. They can be driven in both directions. The typical oil consumption, if you didn't recover the oil, what's passing through the pump might vary anywhere from maybe 75 to 213 cubic centimeters per hour. So again, you're going to have to prevent depleting the engine of oil. Some of the pumps are for vacuum purposes, or at least they're best designed for vacuum. For larger volume pumps, they'll support both pressure and vacuum sides of it. So if you want to use a pump for maybe de-icer boots for inflating them and also driving the gyro instrument, it's possible to do that. Generally speaking, overall, they'll support 10 inches of mercury for maximum on the vacuum side. And if we were to measure pressure in vacuum on the pressure side, maybe 16 inches of mercury. The couplings that you find installed on them, you'll find either a tongue-style connector that goes to the accessory drive, the ones that are splined, and again, sometimes they'll have a spring in the drive end of it to minimize the torsional vibration on the pump. The lubrication test is kind of important. Again, before the pump is installed, you have to verify that oil is being generated and running through the pump. But again, it's a necessity for cooling and also for sealing the veins in the pump. The average life is difficult to calculate, but what I can tell you is they last a long time. On average, anywhere from 1,000 to 1,200 hours of operation without anything ever happening to them. The other thing that's great about them is they don't fail just immediately. Usually there'll be a very, very slight degradation and overall flow that comes out of the pump over a long, long, long period of time. And so it doesn't just catastrophically fail. These things last for a long time. But again, their downside in order to manufacture them and use them, they're very expensive to manufacture. There is one current manufacturer out there of them. It's a company by the name of Airwolf, I think. I think I got a picture for you. And they've got an STC conversion for a lot of aircraft that originally had these wet pumps in them, and there is no dry pump available as a substitute for it. So you can see what they use. It's expensive. The last time I priced this thing out, it was $1,500 or so, $1,600 That was years ago. And it requires, again, an air oil separator. 3 ports on it. One port that goes into port for oil and air, the other port is clean air coming out, and the port down at the bottom is pretty much a drain port that goes back to the engine sump. But that's what they use as a somewhat of a modern replacement. Something else, anything else about these pumps that's kind of unusual? Not really, just expensive. This is a picture of a suction regulator, and again, if we're pulling air through the instrument case, this is our method of controlling vacuum in the circuit. Most of these things for general aviation aircraft are set so that the vacuum gauge will read about 5 inches of mercury. That's usually the required amount of vacuum for a lot of vacuum, or for the vacuum instruments. The range that you see on the suction gauge will go anywhere from maybe 4.7 to 5.2 inches of mercury for the green range. However, for most aircraft that I'm aware of anyway, what you'll see is the suction regulator is adjusted to about 5 inches of mercury. So that's what it does. Again, we're using it for gyro instruments, usually the artificial horizon and the directional gyro. And we may also be using or controlling vacuum as well for pneumatic de-icer boots. With those pneumatic de-icer boots, there has to be something to help hold the boots deflated against the leading edge of the wing when they're deflated. So they generate a vacuum or a low pressure to hold them against the surface in the cycle of operation. So it isn't just so much that they're inflating the boots to break ice off. In the cycle of operation, the distributor valve will shift to a vacuum position, and we have to supply vacuum in order to prevent or at least allow the boots to conform to the leading edge of the wing. For dry pumps, well, dry pumps are, again, kind of an innovation beginning right around 1970 or so. Airborne, I think, was probably one of the first manufacturers of vane pumps. Most of the vane pumps that are out there that are dry have canted vanes in them, and you can see that the slots that are in the rotor are at an angle. So again, supposedly what it does, it provides for more life in the pump, specifically because it's supposed to reduce the tip speed of the vanes. The vanes themselves can be made out of carbon, and more commonly as well, the rotor itself is made out of graphite too. What holds the vanes in position against the case wall in operation would be just centrifugal force. So as the vanes rotate, the vanes move out, and then air is brought into the pump from outside, ambient air, and then as the rotor continues to rotate, the vanes move in order to slightly compress that air, and then ultimately the air is discharged out at the outlet of the pump. I used to tell students that vane pumps that were dry were not overhaulable. You couldn't overhaul them, but that's not true anymore. Years ago it was. The pumps were designed to be pretty much throwaway pumps. Once they reached a particular TBO, or a recommended TBO for the pump, the pump was considered to be, should be replaced at that particular time. And there was no overhaul permitted in the field of them, nor any factory approved overhaul from the manufacturer. But things have changed since. They now have vane pumps that are dry pumps that are, in fact, you can, the manufacturer permits overhaul, and in some cases even field overhaul where it can be done by a technician in the field. So we'll talk a little bit about that too, but I just wanted to give you kind of a picture of what these things kind of look like. What makes them kind of unique are the graphite or carbon vanes that they have inside of them. The way that they check the pump internally for wear is by a depth measurement on many of them. On some of the pumps, these dry pumps, they have a plug that's mounted in the pump itself. When you remove the plug, it allows for the insertion of a tool or sometimes a caliper type device in order to measure the length of the remaining vane that you have inside of the pump. And there's usually a specified limit, but sometimes they have a plug that can be removed for operation. Very important if you're checking the wear status of that pump, not to rotate the pump while that indicator or that measuring device is installed on the port. You can probably figure out exactly what's going to happen. You'll probably break the pump. The pumps are usually fitted with Teflon oil seals in some places. They may also have a Garlock type seal mounted at the drive end of the pump. Those are extremely important because a major contaminant of the pump that could cause it to fail would be the entry of engine oil. Usually the gaskets that are used with this type of pump have no holes in the gasket to prevent the entry of oil. But occasionally somebody will make a mistake and they'll allow a gasket that's got holes in it for use with a wet pump to be installed, and or well, I'll leave it at that. And there's always the potential for oil getting inside of the pump. Also, too, if the Teflon oil seal fails or if the Garlock seal fails, a good entry point for oil inside of the pump. It's immediate death for the pump. It'll kill it. So again, you have to kind of guard against any type of contamination getting into the pump. Also, too, with any of these vane pumps that have got canted vanes on them, you have to be very careful about rotation of the drive shaft of that pump. If you rotate the drive shaft opposite the normal direction of rotation, there is some danger of possibly breaking the vanes inside of the pump. The manufacturers of many of the pumps recommend against repetitive rotation of the pump opposite normal direction of rotation. If you do that, you can have a knife edge that's developed into the vane, and you'll cause the vane to possibly be sheared as it passes either the inlet or outlet port of the pump. So again, it's not wives' tale that you shouldn't rotate the prop opposite normal direction of rotation. I don't know what to tell you to do for mag timing, because I think you realize with many magnetos you're going to have to bump the prop in order to get the piston in a particular position for mag timing. But I would strongly recommend that you don't rotate the propeller repetitively opposite the normal direction of rotation for fear that you might in fact damage the pump. So just don't do that. Not a good idea. Another thing too that will damage a lot of these pumps would be improper installation of the pump. If they've got, somebody has used Teflon tape, here's a good example, on the connectors that have gone to the pump itself. That piece of Teflon tape that you're using for sealing could shear itself off, and as it does, it fouls the pump internally and will cause failure of the pump. So it jams against the rotor and the vanes against the wall, and again, it will cause failure. Another thing too is dropping that pump. If you're not careful with it and you drop it, just like with a spark plug, you may internally fracture some of the component parts. In this case, the rotor. With the spark plug, I think they're more concerned with the ceramic insulator that they have, but nevertheless, you wouldn't want to install it. When you are installing the fittings on this pump as well, we never grab the pump around the case itself with the jaws of the vise. What we'll do is we'll use a padded protector on the jaws of the vise, and then grab the pump around its flange rather than across the pump body itself. Because again, you can possibly crush or damage the vanes that are inside of it. So you have to be really careful with these things. Anything else? Oh, here's a picture of that drive coupling that they use on these pumps. On one particular manufacturer of pump, and I can't remember who it was, that drive coupling is designed to shear at torque loads that are better than 250 inch-pounds of torque. There's another manufacturer that's got a slightly different specification for when the thing shears at, but that device is really what makes it like the shear shaft in a gear-type pump. If the pump should bind internally, this is the sacrificial element that does in fact fail when the pump seizes internally. Those are replaceable, by the way, too. You can buy them. I think some of the overall kits may in fact even have them in them. And again, it's just a plastic coupling that separates, or at least allows you to join the rotor of the pump with the drive. So, but they're replaceable. Anything else that's kind of unique about them? The decal that you find on the pump, sometimes they're temperature sensitive. If that temperature decal turns black, it may indicate that the pump has been overheated, and you may wonder, well, what would cause it to be overheated? Well, the air that's entering into the pump is really not only useful for driving the gyro instruments, but the air that's entering is also the source of cooling for the pump. So if a line has been pinched or it's been mangled in such a way that it's been folded over internally, you not only aren't delivering any airflow to the pump, but you're also cutting off the source of cooling for the pump too. So again, the pump could, the decal could turn itself black. When you're washing down the aircraft engine as well, you have to be kind of careful. There are slots in near the base of the pump that provide for cooling. And again, they're supposed to be open when the pump is in service. However, good practice would be to cover those areas if you're going to wash down the aircraft engine with Stoddard solvent. Because again, we don't want to have any potential for contaminants getting anywhere near the drive shaft of that pump. Again, that Teflon seal might be damaged, or possible that Stoddard solvent could get in. We just don't want it there, so be careful. Okay. And anything else? This is what they do for an overhaul. Some of the airborne pumps that were previously manufactured have a field replacement kit for overhaul, and you can now overhaul them. However, be aware too, if the pump body itself has been damaged in any way, this overhaul kit isn't going to really help you. So it's possible that the pump housing that's kind of an oval shape has got either gouge marks in it, or it's not serviceable. So really just understand that all you're replacing in many of these overhaul kits is the rotor, the vanes, the coupling, and maybe the gasket that kind of goes onto it. So again, you have to do a very thorough inspection before you attempt to do any type of overhaul, because this may do nothing for you. Okay. A little bit about the vane pumps that are dry. They require regulation just like you have to have for any other type of constant displacement pump. The vanes and the rotor are usually both made out of graphite. The Sigma-Techs usually have an aluminum rotor in them, but most of the others, Rapco and everybody else uses a graphite rotor. Not all the pumps are bidirectional, so again, be aware. Some pumps have canted vanes in them, and again, they're designed for usually one direction of rotation only. There's a standard spline drive mounting. It's AND 200000 for the spline drive for it. What they use at the shaft in order to prevent the entry of oil is usually a Garlock seal. It's a special type of seal that has a kind of a wound spring inside of it that makes it conform to a particular shape, and works really well as long as it's intact. Some of them have Teflon oil seals in them. The average life of these pumps, maybe 300 to 400 hours, but there's some other things that are kind of peculiar to it, so you have to be kind of careful. Some pumps can be overhauled by a certified repair station only. They can be damaged during installation and when in service. And probably one of the most important things, the failure mode for this pump is unpredictable. You don't know when. Remember what I told you about the wet pumps. They degrade in performance over a very long period of time, almost unnoticeable. Eventually, yeah, the gyros are going to tumble because you can't maintain the required pressure of vacuum, but it takes a long time for that to happen. In the case of vane pumps, when they fail like that. That's it, they're gone. Usually with a puff of graphite and they're done, that's it. And it can happen in flight, so just be aware. So again, I wouldn't recommend trying to cheat death by exceeding the manufacturer's recommended either replacement or overhaul periods for their pumps. Because again, if they fail, that's the end of the hunt. They fail like right now, and that's it. Anything else with them? Average cost, I think anywhere from say $400 to about $1,100 on a lot of them. That would be a typical cost, but they vary greatly depending upon the type of pump, what they're used to support. Some of them, they're larger capacities and will provide vacuum and pressure for instruments and also boots. But that's what I can tell you. Causes of overheating. Again, these pumps require air, so if the filter is dirty in the circuit, you're not going to have the airflow that's required for the pump, and guess what? It's going to overheat. As I mentioned too, if any of the hoses have been kinked or flattened, sometimes too that'll cause a lack of airflow for cooling purposes. The regulator, if it's a vacuum type regulator where you've got the regulator closed completely off and you're not allowing any ambient air in, again, another reason. Some people think they've got to crank down the regulator, and if you're doing that, sometimes really what's the problem is the filter is dirty. So you're thinking you're adjusting something, and really you're not doing much other than cutting off the airflow that's required for the pump. Broken carbon vanes or rotor, what caused that? The pump has been dropped. Again, possibility. Teflon tape used on the fittings, bad news, so don't do that. If you have to use any type of lubricant, the only thing that's usually specified would be something like silicone spray on fittings. That would be about it. You never want to use any type of solid or paste type of lubricant, anti-seize or things like that. Not a good thing to use. So Teflon tape, not good. Engine cleaning, and you didn't guard the cooling ports on the pump. Well, again, the liquid that you used for cleaning got in the pump, it killed it. The case was clamped in a vise. Poor pump overhaul. And again, if the case cavity has been worn, that overhaul kit isn't going to do a damn thing for you. So again, not good. If you've got excessive engine oil in a wet pump where it just won't get itself out, sometimes you've got a leaky mounting flange oil gasket on that pump. But again, it's kind of peculiar just to wet pumps. Here's the drive, or at least it's been blanked over by a blanking cover, but it's an A&D 20000 drive pad, and again, that's kind of standard for what you'd find for most of the pumps. This is also important to know for direction of rotation. This applies not only to vane pumps, but also pumps in general. When you're looking at what's specified as clockwise and counterclockwise on any pump, you don't look at the pump this way. So we're not looking at that. Actually, I should say you are. What you're not looking at is the drive of the pump itself. So you're looking through the pump in order to determine the direction of rotation. So let's say, for example, we're talking about left-hand or right-hand or clockwise or counterclockwise rotation for any pump. Clockwise rotation would be this way, as looking through the pump itself, not looking at the drive shaft of the pump. There's only a couple of accessories in aircraft where you're actually, where they reference clockwise and counterclockwise by looking at the drive end of the accessory. What accessories would those be, by the way? There's only two that I'm aware of. Which ones? Magnetos would be one. What else? Aircraft governors. That's about it. So if you're talking about like a prop governor, or you're talking about a magneto, usually direction of rotation is viewed by looking at the drive end of those particular accessories or appliances. So for example, if you take a look at magneto, this is a magneto designation number. The R indicates right-hand rotation. What you're looking at is the drive end of the magneto. But again, in the case of pumps, what we're looking at for rotation, you're looking through the device itself. You're not looking, or at the accessory drive. You're not looking at the drive end of the pump. Does everybody kind of get that? Okay. All right. So that's it. And what else do I have for you? Just some recommendations from Airborne, even though they don't make pumps anymore, been absorbed by another company. Again, some ideas you might want to kind of keep in mind. Change filters in the system. Never clamp the pump across the body of the pump. Use the flange of the pump for clamping purposes. Teflon tape, any type of sealant, plumber's putty, no good. You wanna make sure that you use silicone spray. This is also important too. The fittings that go into a vane pump are usually tapered pipe thread, NPT type threads. You don't wanna tighten those things greatly because there's some danger of cracking the housing of the pump. It's true that they're pipe threaded and they get their sealing ability by tightening them, but if you go too far, it's possible that you can damage the pump. We've got also quite a few master cylinders out in the shop, and they have that malady. If you take a look very closely, there's nothing wrong with a master cylinder, but somebody has torqued the fitting down at the bottom with a lot of force, and what they've done is they've cracked the casting, so not much you can do at that point. Lock washers, usually new ones when you're gonna install the pump, so make sure that all the lock washers have been replaced. The pump inlet line should be cleaned thoroughly. This is especially important with dry pumps because if there's any carbon particles that are left over that have embedded themselves or at least lodged inside of the hoses, you can cause failure of the new pump. Blow out all the hoses before you install them. Be aware too that really old hoses, the internal, my God, class dismissed. You're gone. Okay, you're out to the shop right now.
I'm gonna be here.
Too late? Too late?